Hello, people. Welcome back to Datafied YouTube channel and the fourth week of our learning of SQL for data analytics. Let's jump over to the classroom as we look at the second module, which is Introduction to Set Theory for SQL. Throughout previous videos, we've dealt intensively with SQL join statements. From this particular video, I'd like us to look at in set theory. Okay, I believe that you all had the opportunity to learn about set theory in your elementary school. So in this video and subsequent ones, you would learn how to apply the concept of set theory in SQL. Let's view the materials as we explore further. Now, here are the learning objectives. In this section, you would learn how to, you will understand the use of set theory in SQL. You learn how to apply the union, intersect, and except operators on a database. And finally, you know how to apply the rules of set operations in SQL. So this section is structured as follows. We'll begin with introduction to set theory. Then we'll delve into the union operators, the intersect operators, and the except operators. And we'll look at some use case uh, in SQL. So I have attached a material where we've dealt a lot with SQL, all right? And we would also explore the application of SQL, the application of set theory in SQL with a new database. So in this video, I will be introducing you to the database and we'll have an overview of set theory. Then we would have some other shorter videos where we explaining each of these set operators with SQL or in SQL. Let's go ahead and open up this file first. We'll come back to the database. I will talk about the Northwind database. Let's get into the material. So here's the material, and it's titled Introduction to Set Theory, Datafied Academy, Collaboratory. So this material was actually prepared in Google Colab. So you can find out more about Google Colab. But I have decided to attach it here as a PDF file because I don't want any piece of it to be altered. All right, so again, we've seen the learning objectives and the outline from the previous classroom. Let's just go into the introduction of set theory. All right, so here we said, although you can interact with the rows of data from a database table or from multiple tables joined together using the join statements, relational databases are really centered around sets. In this particular section, we will learn about set theory operators, namely the union, the intersect, and except in SQL. These fundamental operators have been derived from set theory and are used to perform various operations on a database. Before we jump into the use of set operators in SQL, let's go over and look at the theory behind it. So what exactly is set? What is set? All right, or what is a set? Fundamentally, a set is a collection of objects, each of which is an element of the set. For example, we have the set of outcomes of a single dice roll is given by the following collection: numbers 1, 2, 3, 4, 5. 1 is an element of this set, but 7 is not an element of the set. So when you roll a die, when you roll a fair die or a die, either fair or unfair die, you will have this collection of outcomes. That is six-sided die. You could have a 1 show up, a 2 can show up, a 3, 4, 5, or 6. You can't have a 7 show up in a six-sided fair die or six-sided die. All right, that is a set. Now, also another example of a set is a set of possible traffic light signals. So, for any traffic light has these three signals or light. Yeah, these light signals: red, amber, and green. So green here is an element of this set, but purple is not an element of this set. So these are some basic collections or examples of sets. There's a concept referred to as a subset of a set. A subset of a set is a set that's wholly or that entirely contained in another set. When you have a smaller set that's entirely contained in another set, we call such a set a subset of that set. For instance, the set of we could have the set of datafied academy students of January cohort. Okay, now I might be interested to say, okay, out of the January cohort, I want to get a subset of those students who joined around February. Now, by extracting the students who joined the January cohort in February, we have a subset, because out of the entire set of January cohorts student datafied academy students, we could get a smaller set out of it. So the examples from the examples posed above, the traffic light signals, we could form a subset of just amber, all right, and a subset of just amber and green, and a subset of green and amber. So all of these smaller sets, green and amber, or only amber or amber and green, they are subset of the set of all possible light signal. But this subset, red, purple, is not a subset. I mean, this is not a subset of the set of all possible light signal. All right. So that is just what a set and a subset is. So whenever you're talking about collection of well-defined items or objects, that is what a set is referred to as. And if you're looking at smaller collection of smaller units or smaller, members of that set, you also have that as a subset. Please note that for every given set, the empty set, excuse me, the empty set is a subset of any given set. So what do I mean by the empty set? I'll show you what notation is used to represent the empty set. The empty set is usually denoted with the 5 brackets. Let me show you what that means. All right. Hold on a minute. All right, great. So here is the symbol that is used to represent the empty set. We call this empty set. Either we use the 5 brackets, the 5 symbol, or empty curly brace. So this is an empty set. All right. And if I have a set A, for instance, this empty set is always a member or an element of A. This is how to write it. All right. This curved E, this is a member or element of member, or member or element of member, or element of. All right. So the way I read this, I say this: the empty set is oh, sorry, not member. Sorry about that. The empty set is a subset. A subset. That's the so I mean to say subset. The empty set is a subset of set A. Okay. The empty set is a subset of set A. Okay, so the elongated C symbol represents subset. And also, A itself is a subset of itself. Okay, the empty set is a subset of A, and A is also a subset of itself, just like the other example we discussed earlier. That is the outcome of rolling a fair dice. We have 1, 2, 3, 4, 5, 6. This is a set. Now, this entire set is a subset of itself. It's containing itself. Do you understand? So this is one concept of a set that's very interesting. Any set you see is contained in itself, and the empty set is also a part of the subset of that given set. Okay, so that is that. We have subsets, and I believe you understand the concept of a subset. Please understand all of these concepts, because we shall look at them. The application of these concepts in sets in SQL. So from a set theory perspective, you can consider a database table as a set. Now, do you see the reason why we explain the concept of a set? We can consider database table as a set. So if we're looking at the Chinook database, for instance, if you're looking at the Chinook database, then we would say that we have 11 sets because there are 11 tables in the Chinook database. Am I communicating? 11 sets. And those sets are the artist set, the album set, right? The media type set, and so on. So we can consider that to be a set, right? And each role or each of its role as individual elements. So the roles that make up a table can be referred to as individual elements in that set, that table set. Now, this way, queries are a way of selecting a desired subset. So whenever you write a query, you are able to pull a subset of that set. I'm very sure that you'd have heard me mention subsets quite a number of times when talking about writing queries. So you're trying to get a subset of a table or portion of rows of data in a database. So in general, the results set of a query can be considered as a new table that has similar characteristics as a standard database table. This query result is now a set and can be used to write new queries. So these are the three major set operators that we'll be considering: the union of two sets, the intersect of two sets, and the except, which is called set difference of two sets. So when we say the union of two sets combines all the members of sets A and B, removing all duplicates. I'll quickly give an example. So if we have two sets, for instance, if we have two sets, let's get ourselves two sets. Set A and set A contains the following numbers: 1, 2, 3, 4, 5, and 6. And then we have set B. Set B has the following numbers: 1, 3, 5, 7, 9, and 11. Okay? Now, to take the union of A and B, set the union of A and B, A union B, is equal to the combination of all the members of A without repeating any value. So I will begin with the smallest number. 1 is present in both sets. Just pick 1, even though it's present in both sets. I don't need to repeat it. Then 2 is in A, pick 2. 3 is present in both, pick 3. 4 is just in A only, pick it because it is in one of the sets. Then 5 is just 5 is present in both, pick 5. Then 6 is only in A, pick 6. Then 7 is in B, pick 7. Then 9 is in B, pick 9. And 11 in B. So you can see this is the combination of the members of the two sets A and B without repeating any value. You don't say because one appeared in both sets, then you pick 1 twice, or because 3 appeared in both sets, you pick 3 twice. No, you just pick the members, combine them without any duplicate value. This is what we refer to as the union of two sets. The union of two sets. I hope this makes sense. All right, so let's get back to it. And then when we talk about the intersect, the intersection of two sets, intersection, this is supposed to be intersect, and not intercept. Well, we could look at it from the angle of intercept. So the intersect of two sets, okay, the intersect of two sets is picking the members that are common between both sets. So A intersect B is equal to the elements that you find common between both sets. So 1 is in A and 1 is also in B. It means one is qualified to be in their intersect. 2 is in A, but 2 is not in B. 2 is not qualified to be in the intersect. 3 is in A and 3 is in B. It means 3 is qualified to be in their intersect. 4 is only in A but not in B, so it doesn't qualify. 5 is in both sets. It means 5 is qualified to be in their intersect. And that is all because there is no other member or no other number that can be found in both A and B. So it means that the intersect of A and B contains just 3 elements: 1, 3, and 5. That is how to get the intersect of two sets. Then when we talk about the except, which is relative complement, the relative complement of two sets is when you take out the, so if I want to get the relative complement of A relative complement B, that is A except B or A minus B, simply means taking out all the elements in B that are found in A. All right, taking out all the elements in B that are found in A. So shortly, I would explain what that means, or once my board comes up. So you can see everything in A except B. Okay, that is what except means, or we call it relative complement or set minus. Okay, let's just give it some time for my board to come up. Sorry about this board misbehaving. All right, so for our example, all what we do is you can just go ahead and write the elements. Okay, so it's coming up. So for this example, you can see we have the elements in A 1 to 6 and the elements in B all odd numbers from 1 to 11. All right, and there are some numbers that are in B that are also in A. So for you to get the relative complement of A and B, or A minus B, for you to get the relative complement of A and B, so A minus B, so A minus B will be equal to all the members in A except B. So it simply means take out the intersection. Take out the intersection from A. I mean, these members that are common to both sets, take it out away from A. Because one is in B and one is also in A, you take out 1 from A. Because 3 is in B and 3 is also in A, take out 3 from A. Because 5 is in B and 5 is also in A, take out 5 from A. So the remaining members, 2, 4, and 6, is the relative complement of A and B, right? That is A minus B. Now, for us to get B minus A, we do the same thing. All the elements that are found in A that are also in B, you take them out, expunge them, all right? So 1 is in A, 1 is also in B, take it out from B. Then take 3 out, take 5 out. So we'll be left with 7, 9, and 11. With this symbol or this simple demonstration, you have seen that A minus B is not equal to B minus A, which means that the relative complement or except operator of set function is not commutative. Okay, it is not commutative. So these are the three basic operations we'll be looking at: the union, the intersection, and the except or the relative complement of two sets. Okay, so yeah, we are almost there. We just need to go over some rules before we get started with set operation. Okay, so we are going to look at these rules, some set rules, in the next video. I'm trying to keep the videos as short and as simple as possible. I hope with this overview video, you've been able to recall some of the concepts you know about set theory, and you now understand the basic three basic operations: the union, the intersect, and the set minus or except or the relative complement of two sets. All right, thank you for watching this. I will see you in the next one, where we'll talk about the basic rules and then begin to look at the application in SQL. Please don't forget to like, comment, and share this video. And I hope to see you in the next one. Do have a wonderful day. Good day.